So in this video for Chapter 6 review, I want to concentrate on empirical formula and molecular formula calculations. So here's an empirical formula calculation. We are given the mass of three different elements: carbon, hydrogen, oxygen. Pretty classic setup, okay? Something I've said in previous videos: when in doubt, calculate moles. That's what you're going to do here. What we're after is the empirical formula, where we determine X, Y, and Z, these numerical values that tell us the simplest ratio of the atoms in the compound for this sample. These values here are basically molar values. We're using the concept of a mole to determine the ratio that these atoms come together. So let's do that first step. Let's calculate the number of moles based on this information. So I have carbon, hydrogen, oxygen, 27.8 grams of hydrogen, 220.2 grams of oxygen. Calculating moles, I'm going to divide by the average atomic mass. It's on the periodic table for each one. And I'm going to add the units here just to emphasize what I'm doing. So, what happens when you divide by this number from the periodic table? Basically, what you're doing is you are canceling grams. And you're setting up a mole to mole to mole ratio for the three atoms. X, Y, and Z are the molar, or is the molar ratio. Now, when you first do the mole calculation, you don't get whole numbers. Okay? I'm going to use a few extra sig figs than what's needed. You do not want to round at this step. If you round to 13, 27, and 13, it won't necessarily work out too well for you. X, Y, and Z, anytime we see a molecular formula, it's always whole numbers. These are not whole numbers. So what you have to do, and it's illustrated down here in the rules, divide by the smallest number of moles here. So this one's smaller. Let's just divide through by it. One term that's used for this, you're normalizing the data. You're setting one thing equal to 1, and then everything else is going to be a multiple from that lowest amount, that smallest amount. Now, obviously, I don't have enough room here. Let me go ahead and continue down here in red. So this is going to equal 1. This is also going to equal close to 1. I'll just write out the full number. It's basically 1. And then this is going to equal to essentially 2. Now you sort of saw that trend, if you're just looking at the number, that it looks like a 1 to 2 to 1 ratio. But by dividing by that smallest number, then you sort of tighten up that ratio where you can clearly see the 1 to 2 to 1 ratio. So now I know my X, Y, and Z. C1, H2, O1, or CH2O. Now this doesn't tell me what the molecule looks like. It only tells me what the, relationship, the ratio between the carbon, hydrogen, and oxygen atoms are in the, or relationship is in the molecule. To know exactly what atoms are in the molecule, I need another piece of information, and that is what's called the molar mass. So I want to do this example here, the second one. So now I have a compound that's made up of carbon, hydrogen, and nitrogen. I'm not given the mass here. What I'm given is the percent. So the trick that we use, the technique that we use, is we say, well, if you had 100 grams of the sample and then you determine the percent by mass, then what happens is that the percent would equal the grams of that 100 gram sample. So the bottom line is convert the percent to grams and then do your normal calculation. Let's start doing that. I'm going to go a little faster here. Okay, so the molar amounts here. You don't see this very often, but when I round off to four significant figures here, then carbon and nitrogen are the same number, and they are the lowest numbers. So we divide by that all the way through. And then what happens is we get a 1:4:1 ratio in our calculation. Actually, this comes in at, 3.996. Okay, that's close enough to 4. Right, we're looking for whole numbers. So here's our empirical formula. Now, what the problem is actually wanting is the molecular formula. To go from empirical formula to molecular formula, what we have to do is we actually have to determine what's called a multiplier, this n value here. And then this is going to give us our molecular formula. And I'll still do the, x, y, z in terms of these numerical values. And then the multiplier has this formula here, molar mass divided by the empirical formula molar mass. Okay, now we've seen what the molar mass is, right? That's just doing this, right? Break apart each element, bring in the average atomic mass from the periodic table, multiply together, add together, and then that's our mass there, our molar mass for the compound. Now in this problem, the molar mass is given, right? So that is that guy. The empirical formula mass, well, that is taking this information, right? We got 1 carbon, 4 hydrogens, and 1 nitrogen. So 12.01, that's the weight of 1 atom of carbon, 4.04, 4 atoms of hydrogen, and then nitrogen is 14.01 from the periodic table. Add those up and you get 30.06 grams per mole. And so now the multiplier, molar mass, empirical mass, and that is equal to approximately 2. What does it look like? How do you use it? Well, you are going to take 2 on the outside, and it's being distributed to each of the atoms within the parentheses. So 2 times 1, 2 nitrogen, 2 times 4, 8 hydrogens, 2 times 1, 2 carbons. And that is the molar mass, or the molecular weight, the molecular formula for this compound. Off the top of my head, I cannot tell you what this molecule is, but I can tell you that these are it would be the exact number of atoms that would be used to actually write the full molecule up. And that's it. Thanks.